Good morning. This is your Stat Sensei, Mr. Spensei, and this is Standard Normal Problems, and this is our classwork. So, X is normally distributed variable with a mean of 30 and a standard deviation of 4. Find the probability that X is less than 40. So, really, we should be defining the variable, and I'm not going to on these just so that we go through them a little bit quicker. So, they're telling us the probability X is less than 40. So I'm going to write down my Z formula. Z equals X minus mu over sigma. I'm also going to draw my picture. And they're telling me my mean is 30. But we have a 40, so 40 is above it. That's my X value. And they said less than. So I have this whole area. And please remember, we're shading to negative infinity. So we want the probability that Z is less than 40 minus 30 over our standard deviation of 4. So I'm going to do this as a stat test z-test. There are other ways to do it, but stat test z-test. And I press enter. And they tell me my mean is 30. My standard deviation is 4. But my x is 40. And we have the less than highlighted. Make sure you do that. I'm going to press calculate. And I have the probability that z is less than 2.5 standard deviations. So my z-score is up there at 2.5 equals 0.9937 or 9938. I'm going to truncate 0.9937. All right, the next one, they want the probability that x is greater than 21. So I'm still looking at the same problem or the same scenario. We have a mean of 30 and we have an x at 21. And we want to be greater than that. So they've already given me my probability statement. I already have z equals x minus mu, so I'm going to start plugging in. So the probability that z is greater than, because that's the greater than, 21 minus my mean of 30 over the standard deviation of 4. So stat, test, z-test, mean of 30, standard deviation of 4, but this is a 20, and I need to change the direction of my inequality to a greater than. And I get a z-score of negative 2.5. So the probability that z is greater than negative 2.5 equals 0.9937. The next one is going to be a bit of work because we have two values. The probability is between 30 and 35. Well, our mean is 30. 35 is up here a little bit. And we're looking for this area right there. Now, I know I could shortcut this because I know 30 is 50%. So I could make it shortcut, but I'm not going to do that. I'm going to do this a long way so that we can see everything in case it wasn't set up this way. So I need to start off with my larger value, which is 35. So we want the probability that z is less than 35 minus my mean of 30 all over 4 minus the probability that z is less than 30 minus 30 over 4. And I have to do two stat test z tests. So we'll start off with the first one. Stat test z test. Press enter. Mean of 30, standard deviation of 4. The first one is a 35. And we have the probability that z is less than 1.25, and that is 0.8943. Now I need to do this side. Stat test, z test. Change that 35 to a 30 because that was the lower end. Oops. And we get a z-score of 0. So the probability that z is less than 0 is 0.5, which is what I told you it would be. So we can subtract these two values, and we can go 0.8993 minus 0.5. And we end up getting 0.3993. I will show you the fast way. This is good for free response tests. This is what you need to show. But if you wanted to do a multiple choice test and you wanted to do it fast, you could have gone second VARS, normal CDF. My lower bound was 30. My upper bound was 35. My mean was 30. And my standard deviation was 4. And if I put that on a multiple choice test, I'd get 0.3943. Oops, I probably misread that. Oh, I did misread that. That should have been 0.3943 because that was a 4, not a 9. All right. So the same answer. All right, looking at number 2. A radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90. And by the way, in order to use the norm CDF or the Z test, they have to be normal. And they just told us it was. With a mean of 90 and a standard deviation of 10. What is the probability a car picked at random is 100 kilometers or more? So I mark 100, that's above 90, and I'm shading up to positive infinity. So Z equals X minus mu over sigma. And X is the speed of the car. That's what we're interested in. We're going to plug in probability that Z is greater than 100 minus our mean of 90 all over a standard deviation of 10. And I'm going to do a stat test Z test, stat test Z test. And the reason I do this is because I really want that Z score. So my mean was 90, standard deviation was 10. We have an X of 100, and we're shading up. And I get a probability, my Z is 1. Probability that Z is greater than 1 equals 0.1586. There's our answer. Going on to number 3, for a certain type of computer, the length of time between charges of the battery is normally distributed with a mean of 50. So they're telling us it's normal. That's super important. We have a mean of 50. And a standard deviation of 15. John owns one of these computers and wants to know the probability it will the length of time will be between 50 and 70. Once again, I could shortcut this because his lower bound is at 50. But let's go ahead and write this out. The probability that 50 is less than X is less than 70. All right, so I need to break this up into 2 Z-scores. So I'm going to do so. I'm going to change pen colors if I have one. There we go. So the probability that Z is less than 70 minus my mean of 50 divided by the standard deviation of 50 minus the probability that Z is less than 50 minus 50 over my standard deviation of 15. And I'm going to have to run 2 stat test Z tests. All right, so here we go. Stat test Z test, press enter. My mean was 50. My standard deviation was 15. My X is 70. Make sure we had the less than because that's what we show as our inequality. And I get the probability Z is less than 1.33 equals about 90%. So the probability that Z is less than 1.333 is 0.9087. And then I have to do the other side, minus the probability. And so we're going to go back and run a stat test Z test. Stat test Z test. In this case, our X is 50. Everything else remained the same. And that's our Z score is 0. So the probability that Z score of 0 equals 0.5. Probability Z score is 0, and that's minus 0.5. and that equals 0.4087. Now, once again, the fast way. Second vars, normal CDF. Only do this on a multiple choice. Don't do this on a test, at free response. 50, 70, mean of 50, standard deviation of 15, 0.0487. There it is. Just what we have. All right. But it's much faster that way, which is really important on a multiple choice. All right, the length of similar components produced by company are approximately normally distributed with a mean of 5 centimeters and a standard deviation of 0.02. So, mean of 5, standard deviation of 0.42, and they want to know what's the probabilities between 4.98 and 5.02. Well, that's interesting. That's plus or minus 1 standard deviation. So by empirical rule, I'm expecting this to be about 68% by empirical rule. So let's go about doing this. And I don't have a whole lot of room, so I'm going to scoot way over here. So we want the probability statement is going to be the probability that 4.98 is less than X is less than 5.02. So that's the probability that Z is less than 5.02 minus 5 over the standard deviation, and our standard deviation is 0.02, minus the probability that Z is less than, and boy, I'm going to run out of room. I'm going to change pen color just because I'm running out of room. 4.98 minus 5 over 0.02. Sorry if you can't read that. That's supposed to say 4.98. So let's calculate that first Z-score. Stat test, Z-test. Mean of 5, standard deviation 0.02. And then our X is 5.02, N is 1, less than, calculate, and we get 0.84. So the probability that Z is less than 0.8413 is, the probability of Z is 1. I'm sorry, probability of Z is 1 equals 0.8413. All right, now we need to do the other side. Well, the other side, stat test, Z test, and we're changing that 5.02 to the 4.98. I know that doesn't read 4.98, but that's what it's supposed to be, 4.98 right there. And we end up getting a negative 1. So the probability that Z is less than negative 1. So there's that plus or minus 1 that I was talking about. There's the plus 1, there's the minus 1. And we end up getting 0.1586. Let's subtract those two values. So we have 0.8413 minus 0.1586, and we get 0.68%, which is what I told you beforehand, that we should be about 68%, equals 0.6827. For those of you who want to see it in the shortcut mode, here we go. Second vars, normal, CDF. Lower bound, 4.98. Upper bound, 5.02. Mean of 5, standard deviation 0.02. 68.268. Rounding, not much different. All right. What's the probabilities between 4.96 and 5.04? Oh, that's plus or minus 2 standard deviations. So it should be approximately 95%. So this is at 5. There's my mean. This is 4.96. And this is 5.04. And basically, we want the probability that 4.96 is less than X is less than 5.04. So at that point, I want the probability that Z is less than 5.04 minus 5 over 0.02 minus the probability that z is less than 4.96 minus 5 over 0.02. And we'll run the first one first. Second vars, stat test, z test. Mean is 5, standard deviation is 0.02, but this is 5.04, still the less than. And we end up getting, 2, which is what I said, plus or minus 2. Probability that z is less than 2 is 0.9772 minus the probability. So we got to go back and do this one. We're turning it into a 4.96. And we should get a negative 2. And we do. The probability that z is less than negative 2 is 0.0227. Subtract those values. 0.9772 minus 0.0227. And we end up getting 0.9545. So about 95%. Remember the empirical rule is an approximation, but it's pretty close. And second vars, norm CDF. And we're looking at 4.96 to 5.04. And there it is, 9.544. There it is. All right. The length of life of an instrument produced by a machine has a normal distribution with a mean of 12 months and a standard deviation of 5. Find the probability that it's less than 7. Well, 7 is down here. All right. So we want the probability that x is less than 7, which is the probability that z is less than 7 minus 12, that's my mean, divided by that 2. Stat, test, z test. Mean of 12, standard deviation of 2, x of 7, and we end up getting negative 2.5. So the probability that z is less than negative 2.5 equals 0.006. All right, now this one says between 7 and 12 months. So I'm going to use this information so I don't have to do this twice, so I can speed it up a little bit. So once again, we're at 12. 12 is 50%, so we know that. So really, all I need to do is actually subtract out that value from 0.5, and I'd get my answer. But I'm going to act like I don't know that. I'm going to go probability that 7 is less than x is less than 12. So there's my probability statement. I've already done the 7 part, so I'm not going to redo that, but I'm going to do the 12. So the probability that probability that z is less than 12 minus 12 over the standard deviation of 2. So that's going to give me 0, which is that 0.5 that I told you was going to happen. So stat test, z test, 12 to my x is 12, and I end up getting 0.5. So there's that 0.5. So 0.5000 minus the probability that z is less than 7 minus 12 over 0.2 or over 2. And we know that's 0.0062 right here. So we can just subtract these out. And 0.5 minus 0.0062 is 0.4938. From this point on, I'm going to use the shortcut just to speed this video up. So what's the probability they scored higher than 80? All right, so in this case, we have a mean of 70 right here, standard deviation of 10, and we want to know the probability they scored 80 or above. So that's a probability that X is greater than 80, which is the probability that Z is greater than 80 minus 70 over my standard deviation of 10. Mean 70, standard deviation 10, X 80, but we're shading up, and we get 0.1586. What's the probability they should pass the test? Well, if the grade is a 70, if the passing score is a 70, oh, that's halfway. So that should equals 50%, but we're going to check it out. We want the probability that X is greater than or equal to 70. It'll equal 50%, but we're still going to do it. We're going to get a Z score of 0. Probability that Z is greater than 70 minus 70. Oh, that's 0 divided by 10. So the probability that Z is greater than 0 equals 0.50, and I'll prove it to you here in just a second. Stat test, Z test, change that to 70, 0.499999. That's 50. All right. Probability should fail the test. And this is grades less than 60. Now, we didn't say that up here. So here we did it at 70. We're going to do grades less than 60. So I know they don't correspond, but that's what we're going to do. So grade less than 60 is the probability that X is less than 60. And we want the probability that Z is less than 60 minus 70 over standard deviation of 10. Well, that's going to be 1. That's going to give the probability that Z is less than 1. And I don't remember what that is. So here we go. Stat test, about 16%. But stat test, Z test, 70. And we need to change this to a 60. And we're shading down by our drawing because anything less is a failing grade. And we get about 16%. Probability Z is less than -1 equals 0.1586. All right. The time taken to assemble a car in a certain plant is random variable having a normal distribution of 20. That's supposed to say a mean, it's supposed to be normally distributed with a mean of 20 and a standard deviation of 2. And they're telling me this is 19.5. So here we go. Probability that X is less than 19.5. I'm going to get a negative Z score because I'm below the mean. So the probability that Z is less than 19.5 minus 20 over 2. Stat test, Z test, mean of 20, standard deviation of 2. We have an X of 19.5. And we get a Z score of 0.25. The probability that Z is less than negative 0.25 equals 0.4012. You know what? I have 2 more of these that'll be long. I think I'm going to do them the right way, the way you should do them for the AP FRQ. So here we go. We want between 20 and 22 hours. Here's 20. 22's up here. Now, the interesting thing about that is I know this is 50%, so I'm subtracting out 50% from the 22. So I could speed it up by doing that. Matter of fact, I think I will. So here we go. The probability that 20 is less than X is less than 22. There's a probability that Z is less than 22 minus 20 over 2. minus the probability that z is less than 20 minus 20 over 2. Now, I need to do this first one. So stat test z test. I'm going to change this to a 22. Stat test, don't know what I did there. And I get the probability z is less than 1 is 0.8413. Now, if I do this, it's going to get the probability that z is 0 because 20 minus 20 is 0. Probability that z is less than 0. Well, this is 0.5 because that's halfway. So 0.8413 minus 0.5 gives me 0.3413. All right. The annual salaries of employees in a large company are approximately normal with a mean of 50,000 and a standard deviation of 20,000. I'm just going to abbreviate 50K. What's the percent of the people who earn less than 40K? All right, so 40K is here. So we're looking for the probability that Z is less, actually not Z, probability that X is less than 40,000, which is a probability that Z is less than 40,000 minus 50,000 all over 20,000. Stat test, Z test, mean 50,000. Standard deviation 20. X is 40. And we're a half z-score below. So the probability that z is less than a negative 0.5 equals 0.3085. There we go. And we would expect it to be negative because we're below the mean, so we expect a negative z-score. What percent of the people earn between 45,000 and 65,000? All right. So if I'm drawing my picture, I'm actually going to show y'all something that you probably, no, I don't think I will because it mess things up. I'm afraid I'll mess you up. So this is 50K. This is 45K. This is 65. And so I'm looking for this area. So I want the probability that 45K is less than X is less than 65. So we're going to do the 65 first. So we have the probability that Z is less than 65K minus 50K, that's my mean, over the 20K, minus the probability that Z is less than 45K minus the 50K over the 20. Let's do this one first. Stat test, Z test. We have 50,000, we have 20,000, we need to put in the 65,000. And we get the Z score of 0.75. So the probability Z is less than 0.75 happens to be 0.7733. Next one, probability. So I go to this one and I go stat test, Z test. X is 45,000. And I can get up a negative 0.25 minus the probability that Z is less than negative 0.25. And that is 0.4012. And if I subtract those two values, 0.7733 minus the 0.4012, I end up getting 0.3721. All right. What percent of people earn more than $70,000? All right. So making the picture. So this right here is 50K. This is 70K. And we're shading up. And we want the probability that X is greater than 70K. So that's the probability that Z is greater than 70K minus 50K all over 20K. Stat test, Z test. Changing this to 70,000. Now be careful here. We need a greater than. So the probability Z is greater than 1 equals 0.1586. All righty. I hope that helped and look forward to seeing you on the next one. Thank you.